All right, hello and welcome back. This is another ALEKS topic. It's called Understanding How Electrostatic Forces Cancel. I think this is a great prerequisite topic. The concept that's going to be sort of at play here is really a crucial concept for us to understand for a lot of different things, that we're going to run into in chemistry: intermolecular forces, lattice energies, all that sort of stuff. This is sort of the fundamentals of that. I'm going to go through two different examples of this problem just to expose us to a few more examples. And let's go ahead and get started. So basically the first thing or what this question is asking us to figure out is the charge, the particle that's got the circle around it, the green circle around it. That's going to be what we're answering the question based off of. So there's a little confusion I've heard about that, but basically we're going to take whatever the particle that's sort of down the middle here that's got a green circle around it. We want to know, is there going to be a force pushing or pulling on that charged species? And if there is, we're going to say which direction it's going. And then if there's no net force, it's going to be, we're going to fill in the middle circle there saying no net force is going to be occurring. So in this first one, I've got a -2 charge here, and I've got a -1 charge here. So these are like charges, and like charges are going to repel one another, right? It's just sort of like a magnet. If you put the two similar ends, towards one another, it's going to repel. It's the same idea here. We've got a like charge, so that's going to be pushing it away. So I would choose this circle over here. That's going to be pushing that -2 charge that way. The next one, I've got a +3 charge in the middle with the green circle around it. And I've got two negative charges. So both of these, if I just sort of think about this independently, these two things, these two particles would be attracted to one another. There would be definitely an attractive force happening there. Same thing over here. If I just get rid of this -1 on the other side, there would be an attractive force between this +3 and the -3. So then the question becomes, which one's going to be greater, right? Like if we sort of dropped this +3 on the ground there and said, okay, well, which direction are you going to go? The pull to this side is going to be greater. A -3 charge is going to have a greater pull on that +3 charge. So in net, this one's going to end up going to the right. It's going to be pulled in that direction. Down here, again, the same thing here. We've got a +2 and a -3 and a -2. Just to sort of make sure, we've got 1, 2, 3, 4, 5, 6, 7 boxes between the +2 and the -2, and 1, 2, 3, 4, 5, 6, 7 boxes between the +2 and the -3. So they're equal distant from one another, but the -3 charge is greater, right? Greater in magnitude than the -2 charge. So this would have a net pull to the left, right? That +2 charge. Again, if we dropped it down, what would we expect to happen? It would go that way towards the greater -3 charge. Let's do another example, another set of examples, just so that everything's all clear. So on this one, the first one, we've got a -3 and a +2. So now we've got the same charges. So now what we'd really be worrying about is how close these are. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that would be no net force. They're going to be, these +2s are essentially going to be pulling equally. They're going to be, that -3 is going to be equally attracted to both of those +2s. So in net, it's not going to go anywhere, right? So you do need to pay attention to how far away the charges are, sometimes. All right, here we've got a -3 and a -3. So again, same charges, but now this -3 is much closer, right? So since this -3 is much closer, it's going to be going to the right. It's this +1 is going to be feeling the effects of this -3 much more, right, as it sits there. The last one here, -3, +3, and +1. I think pretty obviously we've got a larger charge. It's closer. Everything's pointing to this -3 charge wanting to go more towards the left. All right, hopefully that helps. Cheers.